Hi everyone, this is Ms. Hefner. I'm here to give you a quick tutorial on adding and subtracting algebraic fractions. Just remember, this is not a substitute for the lessons or the lectures that your teachers have given you. This is just a tutorial to get you ready for the test on Friday, or maybe the final exam coming up in a couple of weeks. So I'm going to switch over to my document camera where you can see some of my notes. And I wrote this out ahead of time because it's kind of a lot to write. So we're talking about adding and subtracting algebraic fractions. And the cool thing is this is old. We already know how to do this. So just like when we were working with simplifying algebraic fractions, we already know how to simplify a fraction. So simplifying algebraic fractions is the exact same thing, following the exact same steps. Same thing with adding and subtracting algebraic fractions. Just as a reminder, the main principle of addition applies here. So, just so we can recall, the only things you can ever add are the same things. And when you add the same things, you're going to get the same things. Okay, and of course, this also applies to subtraction because we know that subtraction is just addition of the opposite. So the main principle of addition applies there as well. So looking at some examples, and of course, we'll say that the directions are add. What if we had something that looked like this? 2 over x plus 1 plus 3 over x plus 1. And so again, going back to the main principle of addition, we can look here and say, okay, we know we can only add the same thing. So first, let's ask ourselves, can we add? Can we add x plus 1s and more x plus 1s? And our answer is yes, we can. And what are we going to end up with? More x plus 1s. The only things you can add are the same things. These are the same things. And when you add the same things, you get the same thing. So when we add x plus 1s, we're going to get x plus 1s. So how many do we have? 5. 2x plus 1 plus 3 over x plus 1 equals 5 over x plus 1. If we look at something like this, we have 3x over 4x minus 3 minus 1 over 4x minus 3. And let's ask ourselves, can we subtract here? Well, the main principle of addition says we can if they're the same. And when you add the same things, you get the same thing, same as subtracting. 4x minus 3 and more 4x minus 3, we can definitely subtract those. And what are we going to get? More 4x minus 3. When you subtract the same things, you get the same things. Well, how many do we have? 3x minus 1. And there's nothing more that we can simplify here. So we would just leave that as it is. What if we had something that looked like this? 3x over x plus 1 plus 2x over x plus 1. Again, we always go back to the main principle of addition and ask ourselves if we can add. Can I add x plus 1s plus more x plus 1s? Of course, because these two are the same things. I'm going to get the same things. Again, always going back to the main principle of addition. And how many do I have? I have 3x plus 2x. Can I simplify that more? Up here in example B, we couldn't. There's nothing we can do here, nothing that's the same that we can add or subtract. With this guy, with C, there is 3x plus 2x. Those are the same things. So we can add those and get 5x over x plus 1. All right. So we know that if we have same things, we can go ahead and add. A key idea, and again, this is something that we already know, is that if you're clever, you can convert. So if we have things that aren't the same, we can definitely convert them. And I am going to start, just like I did with the simplifying fractions, with an example that looks like this. Can I add 2/3 plus 5/7? And looking at that example, I can definitely see that they're not the same things. Thirds and sevenths are not the same, but I do know how to convert here. We've done this before a bunch of times. So I'm going to do that. And I like to do my work off to the side just so that I keep my area up here uncluttered. And in order to get a common denominator, because we know how to convert to common denominators, we multiply the denominators. So 3 times 7 is going to be my denominator, which is 21. And to convert, we're just multiplying by a form of 1. 3 times what gives me 21? 7. I have to put a 7 up here because I have to multiply by 1 to convert, and that's going to give me 14 21st. Same thing here. 7 times what gives me 21? 3. It has to be 3/3 because it has to be a form of 1. So I have 15 21st. So then what I like to do after I've done my work off to the side is say, okay, so now I have 14 21st plus 15 21st, and that gives me 29 21st. Okay, so that's what I was saying. We already know how to do this. So then what happens when we have an example that's one of these algebraic fractions? So what happens when we have an example that looks like this? 2 over x plus 5 over y. Well, as usual, we always want to ask ourselves first, can we add? Just like we said over here, can we add thirds plus sevenths? Can I add x's and y's? No, but I can convert. And the way that we convert, and again, I like to do my work off to the side so it's nice and neat. The way we convert is we just multiply the denominators. So over here, 2/3 times 5 or plus 5/7, I multiplied 7 and 3 to get 21. I'm going to do the exact same thing for these two. So I'm going to follow the same exact process. So I have 2 over x and 5 over y. And in order to get the common denominator, I'm just going to multiply the denominators. 3 times 7 is 21. X times y, it's just xy, right? There's nothing to simplify there. And what do I multiply x by to get xy? Y. And so what does it have to be? Y over y, because when we convert, we're multiplying by a 1. This is 2y. Same thing down here. My denominator is going to be xy. Y times what gives me xy? Just x. And down here, I'm multiplying by x over x, because when we're converting, we're multiplying by a form of 1. And this gives me 5x. So then just like I did over here, let's take a peek. 2/3 times a form of 1, 5/7 times a form of 1. 2 over x times a form of 1, 5 over y times a form of 1. And then I like to take my work up here. I have 2y over xy plus 5x over xy. And is there anything I can do in this numerator to add things that are the same or subtract things that are the same? There isn't, because I have y and x. So I know my denominator is xy, and my numerator is then 2y plus 5x. So I followed the same steps in both of these examples. Let's do one more, just to make sure. We'll use the clean side of the paper here. Let's do one more where it's just all out here on its own. And we will say subtract. So if I have A over BC minus 3 over A. So can I subtract these things as they are? No, I can't, because they aren't the same things. So again, like I know already, I can go back, go off to the side and do some converting. So if I have A over BC and 3 over A, I'm not going to panic. I'm not going to get confused. These are just still two separate fractions. And the way that I get the common denominator here is by multiplying these two together. Well, what's BC times A? Well, there's nothing I can combine there. It's just going to be A, B, C, A, B, C, and that's it. Now I can just do my converting. BC times what gives me ABC? That's A over A, because again, we're multiplying by a form of 1. A times A is A squared. A times what gives me ABC? BC, BC, because that's a form of 1. And right here, I'm going to have 3BC. And again, then I like to pull it up here. So I've kept my area, my side work off to the side so it's organized. So then I have A squared over ABC minus 3BC over ABC. And then I want to ask myself, since I know my denominator is ABC, is there anything up here that I can simplify when I subtract? And if you're not sure, it's fine to just write it and then as another step. So I have A squared minus 3BC. And I see that there's actually nothing I can do here. There's no there's no adding the same things or subtracting the same things here. Okay, so I hope that this helped you with adding and subtracting algebraic fractions. I'm actually going to leave this piece up here so that you can see it if the video is finished. If you want to just kind of look through these notes here, I'll pause it here for just a minute. I hope this helped you get ready for your test coming up and for the final exam. Have a good day.